Right. Hello, everyone here with me. So I'm Symington backend developer, PHP, and GS, Express. And today I'll be discussing about application programming interfaces, popularly called API. And if you are a techie, whether you're into core programming as a front-end developer, back-end developer, you're into software engineering, software development, generally, it's definitely a term that you've heard. If you're a beginner, it's might be daunting and even intimidating the way the word or the term API is thrown around in the software world. And of course, when many people talk about APIs, we talk about something okay that application talk to themselves. And to show you about that before. So APIs are different application talk to themselves. Why that is actually really what APIs are, what they really do, might not be really helpful in explaining to you or giving you a concise idea of what APIs really are. I hope to tell you and explain to you what an API is, and you should be able to know that in great detail to some great extent at the end of my presentation. All right, so let's launch right into it. So this is a problem that I've seen before. Probably you've seen. So you have backend, front end, and you have API. So this is a restaurant, and they have the kitchen and the people making the meals, the chef making the meal, backend guys, right? Doing making things work in the backend. Then you have the restaurant, the designs, uh, the what basically make people comfortable, the chairs, the tables, all of those things on the front end. But then the food being made in the back end will magically appear on the table, right? You're going to have some people who can you can transport those food from where they've been made to the front end and basically do some work. And the interesting thing about that is that in as much as these guys are connecting the front end to the back end, they can do that for basically any front end. So supposing there is another restaurant out there, they can just take some balls and still take the food right to the place without necessarily cooking in that particular place. So this backend can serve multiple locations. That's what that is exactly what API does. So API leave programmers the stress of building multiple infrastructure or multiple databases, multiple for different programs, different softwares, and you can just have a common source that serves as the pool where other application can draw from, basically, and they can even exchange data to themselves. They can talk to themselves using that particular backend. That is basically what it is. So let's launch right into it. So we're going to look at what an API is, how it works, the types of APIs, the types of API protocols, and the common example and then why it is important. All right, so like I said, API is a collection of rules that describe how computer programs and softwares and even computer themselves interact with themselves and speak to one another and communicate with themselves. So it's just like an intermediary layer. It's just like a middleman that connects one computer to the other, one software to the other, front end to the back end, and just essentially let them communicate and exchange data because that's what they're communicating by exchanging data. Essentially, it's either the front end is sending the data to the back end, or it's receiving the data, or it's updating the case to be essentially. That's what an API does. They're communicating that way, sending responses, sending requests with receiving responses. So it makes software development and innovation easier by allowing apps simply and securely communicate data and functionality. So essentially, you don't have to create the functionality from the for your app from scratch. You don't have to create and try to get data from scratch. You can basically use an API to get both the functionality and the data itself. So supposing you need a list of artists or list of song performed by artists, you can use a specified API, for instance, to basically get that and infuse it into your own application without having to go around and try to build the database to basically have that particular structure in place. And essentially, that is true for every other thing. So even functionality of an app, essentially, that's what an API can do. So that way, software development is actually faster. You don't have to create everything from scratch. So a company usually open up their application data functionality to external third-party developers, business partners, and internet department through an application program interface. For instance, recently, WhatsApp they opened up their API for everyone to use. Twitter API has been up and running for some times now, and that is it. That's it basically. And Facebook and social media, universal logins are all there. And you don't have to create a new account. You can basically use the same Google account for all of your accounts anywhere you're going to. It basically work because Google will just share your data with that particular website you're visiting, and you don't have to create a new account from scratch. And that's the way it works. And this are even between different structured companies and third parties. You can even this can also be the case within an organization. So let's say in your own organization, Beacon, for instance, we can have an API that different teams communicate with. Let's say the front end team, maybe even different parts of the front end team can basically communicate using the same API to same endpoint essentially. So now through a specified interface, services and products can communicate with one another and benefit from each other. Functionality. Like I said, so this is exactly the diagrammatic representation of what I've been talking about. So you have your company and you have some data, some functionality that have built some infrastructure for different applications, right? You can use that to serve every single thing. Imagine if you have to build a web application, a mobile app, and one for iPad, and then you have to build a single database for each one of them every single time because you are making, let's say, the app for mobile or for web. Now that is not exactly cost effective. It's not exactly productive, right? So what you can do is that you can have a major pool, like I mentioned before. You can just have a source, let's say a single database, all right, and then that's the endpoint. Then you have an API that can be called upon, that can access that particular database, and every single aspect where you want to use your application is going to call that same endpoint and access the same data. Interesting. So your dayplate, your web app, your game console, your mobile app, smartphone, even car, every single thing, all of your appliances can essentially communicate through the same API and access the same functionality and the same data. You don't have to create a new one for each and every single one of them. So how does it work? So essentially, the way it works is that a client, let's say your mobile phone or your browser, that's a client, okay? Initiate a call, make a request, all right, to the server, okay? And then the server gives the response. It's as simple as that. And how do we do that? I'm going to really explain it due to what we talk about REST APIs. So basically, you have to use a URL or URI, universal resource locator or identifier, that is just a unique address for the resource you are trying to locate or you're trying to manage or update or delete or manipulate or even retrieve essentially. And once your client, your mobile phone, your web application, your browser or server thing, the client make a report, it makes it through that URL. And of course, since it is a uniform resource identifier or locator, it's going to, every single time the call is made through that URL, it's going to always go back to the server to get that particular resource and do what they're sent to do. That's the way it works. So send a request maybe in headers or in the body. If you are filling in your form, let's say you're registering, let's say your name, you're registered as a user. Of course, you're going to send your request through the body. If you're, let's say, searching for a particular product, that's is going to be in the header, right? You are going to have query strings, parameters basically that you're going to put, and that is going to send the request to the server, and then the server makes the appropriate. So if it's to get the data from database or give you some immediate response or through some GC strings to you, depending on how the code has been written, you're going to get a response. If the request is made correctly, there's no any server error. All right, so I've mentioned that after receiving a valid request, the API make call to external program or web server, like I said. Then the server sends the response to the API with the requested information. And then the API returns back that data to the initial requesting application. That is the client. And this is it. So you have various clients, mobile apps, website, desktop. Then you have the host servers on both the screen end. Then in the middle, the intermediary, you have the API. So the API is where like you make a request through it, and then it returns a response back to the client. So this is Postman, and it's a tool we use to test APIs, and this is exactly how it works. So you have your URL there. That's where you call it, or URI, as the case would be, and there's a send button on the right side of the screen, and that is going to basically send a request. You are making a request, right? Then you can see the method. These are like HTTP. This request is made by HTTP, as you can see, and we are doing a GET request. Okay, this GET is going to basically retrieve the data from product, all right, and then we can see data that is returned JSON, JSON data return, then the status of 200, meaning that request was successful. Then we have ID, the name, the price, the stock, the time it was created, the time it was updated, and this is essentially how we make the request. Okay, so this is basically tested in a actual application. This JSON response will actually be now used to display whatever you want to display to the client or to the user, as the case may be. So you have your URI, you have your HTTP method, you send it, and then you get the response. Simple. And these are the status code. Since we're making an HTTP request, HTTP standing for Hypertext Transfer Protocol, because it's a protocol for transfer, and what we're trying to transfer is an hypertext, which you can probably have heard of from HTML. So basically, you're trying to get a file essentially, and hypertext file. Okay, it can be XML, JSON. The response can be those. So 200 to 204 is like a successful. The request was successfully sent. Okay, 200 is okay. 21 is created with something. Then 23 non-authoritative information. And 204 means that we sent a request, but then there is no content from response. Then 400 to 49 is like error, basically. And 500 is also like server error. So 400 is a request error. So you have bad request unauthorized. Let's say you have to do some verification, right? Some API actually requires that you do some verification, and then you have some access token to be able to access the results. And so if you are not authorized, if you are not logged in properly, it will be forbidden, not found, and then that is the URL. It's non-existent. Okay, not found. 404 page does not exist. Okay, and then that is it. So the internal server error service on 500 to 500 to basically have like 75 basically server errors. And these are the codes you get. So when if you get 200, okay, you are going to get the response essentially, JSON. So what type of API? So we have open API, partner, private, website. So open are like free ones. Let's say weather API, many of them out there, Twitter, WhatsApp, recently. So these are like APIs that are free for all, everyone can use for development purposes. You can introduce it into your application. Like I recently made a face detection application using Clarify API, which is available for everyone. So you specify, and many others are open API, which you can use in your, and you can infuse into your own application to create beautiful stuff. The partner means like just created and they share with partners. Private means that within a local organization or just within restricted, very restricted, within confined spaces organization. Composite is very interesting because imagine if you have to make multiple requests via multiple endpoints. That could be very stressful and not exactly efficient in terms of time management. So composite is that you can actually make requests to multiple endpoints, multiple API using one single endpoint. Basically, with one endpoint you can access multiple endpoints. Okay? Interesting and very cost effective, and increases productivity. So those are the types of API. So now we talk about protocol because talking about developing APIs and all over the years, the question has been like, what is the acceptable what are the acceptable rules of confinement to which we should create this thing so that everybody will be able to use them, right? So I'm going to list about 4, but of those 4, 2 are the most popular, the one we use, and I'm going to do one which is by far the most popular, like standard and follow. Okay, so we have SOAP. So SOAP is the protocol. That is very important. It's the protocol. So it's the standard that rules that you have to follow. So simple object access protocol. So it is XML based. All right. So it allows you, it's an XML based protocol, and it allows users to transmit and receive data via HTTP like application before, but not just HTTP, but also through FTP and SMTP. Very, very key. All right, so you can easily transfer applications like that through SMTP and HTTP. In the case of REST, representational state transfer. All right, so these are not exactly, it's not exactly protocol, but it's a set of principles. Okay, so there's no official standard. It's just that once you build the application, it must fulfill some criteria at the very least. And once it can fulfill those criteria, boom, you're good to go. Right? And any application, any API that fulfill this criteria are said to be RESTful, right? Because they adhere to the architectural constraint of REST, basically. So, and with REST, you can make a request via HTTP. What the Postman image I showed before is a RESTful API, right? Using HTTP, then you are going to have the HTTP verb, which is the method get, post, put, delete, right, batch, and so on and so forth to make your request, and then that's going to, send the data, send the request, and then you're going to get a response. So yes, you can send the request also through JSON, XML, and then you can receive it back as JSON as plain text. But the most acceptable, the most common, I won't say acceptable, the most common format of receiving file via the REST API, REST API is JSON, because JSON is language agnostic, even though it is JavaScript object notation, rather. So it is language agnostic, which means that you can easily convert or work with JSON data with any language of your choice, maybe PHP, Node, Ruby, anyone, Go. So you can also have JSON response can be okay. So now, what are the criteria? Now, the first is that you have to use a uniform interface URL. So it has to be one URL to particularly locate the locator of that particular resource, essentially. Okay, that's going to the unique identifier of that particular resource. So another thing is that it has to be a client-server based architecture. So client server means that you have a client, then you have a server. So client is like your browser, your phone, or so, and then you have the server where the request is going to be sent to you. And of course, the request is going to be managed through HTTP only, not SMTP as in the case of SOAP. So in